Okay, gang, we're going to jump right in. This is K1GMM. Sorry about the squeaky chair. Steve here in the ditch in Vermont. I figured I'd do a series of videos. I'm going to push them live so I don't have to record them and upload them. I can do it all in one shot. So I've been getting correspondence from different hammies regarding diversity reception, what I run for an antenna. So I'm going to revisit some things. And I'm also going to show you exactly how I approach this. I have yet to find, I see a lot of people doing videos, and I've done it, I'm guilty, demonstrating diversity. I have covered diversity with a couple videos. And if you go back in my channel, don't ask me where, it's buried deep, probably more than a year ago. I did a nice stream with a guy from the UK who's very skilled with diversity noise canceling. So let's get right into it. So the first thing I wanted to address is there's diversity noise canceling and there's diversity reception. They are two different things. I'm going to share how I approach this. And hey, Andy, how you doing? From the UK. And this is in direct relation to the Apache Labs radios with dual ADCs and the SDR Uno software running the RSP Duo, which has twin ADCs on it. I'm not going to go through the Duo, but the principles are exactly the same. So what I'm going to do is I'm going to show you how I approach this with the Apache Labs. So the antenna I'm running for, regardless of whether it's diversity noise canceling or diversity reception, the antenna I'm running is a 65-foot vertical end fed. It has a 49-to-1 on it, which it should have probably a 9-to-1 is plenty adequate. But the 49-to-1 I had, so I slapped it on there. Now, I have a 1/10 wavelength counterpoise at the base of it. So that is technically a half wave end fed on 40 meters. However, it works extremely well on 75, 80 as well. There is a lot of discussion. You'll hear people say, well, you don't need much of an antenna for diversity reception. You just need to pick up the noise. And that's true. I approach this from a slightly different angle. So how I do it is, if I'm going to have a transceiver with capable of dual receive, two independent receivers, or ADCs in the case of a SDR radio like the Anan, why am I going to put up an antenna that hears only the noise? Wouldn't it be more beneficial to hear the signal as well as the noise with a good strong signal? The reason why I say that is because I didn't want diversity capability on just one band. I wanted the ability to run it across multiple bands. And if I didn't have a noise issue, I would have the capability of diversity receive, which means all of my antennas here are horizontally polarized, but for the diversity antenna. The diversity antenna is a vertical. And what I've been playing with is combining and mixing both antennas. When I don't have to suppress noise, I can use both antennas without running diversity noise canceling. I can run it in diversity reception, and I can mix the two polarizations. Oftentimes that will reduce fading. Now, the very cool part about this type of a setup is that it's you can't see it. It's just a vertical piece of wire that goes up 65 feet, and it goes right through the branches of the tree. You're not transmitting on it, so who cares? Now, a little bit more about that particular antenna. I have two RF one-to-one chokes, one-to-one RF chokes on it. And if you want to know what those chokes, how they're built, you can go to W1VLF's YouTube channel. and they're built on 31 mixed cores. I have one at the feed point of the 49-to-1, and I also have one in here where it comes into the SDR switch. So for the second ADC and second receiver. I wasn't too concerned with suppressing too much noise because it still picks up the noise, as you guys will see. But it also picks up signal as well. Unfortunately, you're not going to see much signal because it looks like the guy's on 80 meters left. I'm looking at the pan adapter, but I'm going to show you basically how the system works. More importantly, I'm going to show you how to configure it in the software, because there's some things with the Anan transceivers that nobody has shown. They just demonstrate how it works. Well, how do you make it work? There's some very important things that I want to show you. So, and this is for you Anan freaks, and the exact same things apply in SDR Uno running an RSP Duo. This is something that's been a long time coming. I've been thinking about it, and with the correspondence over the past couple weeks, I think it's time. So, all right, we covered the antenna. Now, the two principles apply to noise canceling reception, and we are going to go into two aspects of noise canceling. One aspect is narrow bandwidth targeting of a localized noise source across the band. So let's say you're going to a specific frequency and you're in QSO, or you're about to go into QSO with someone, and there's noise literally inside the passband. I'm going to show you how I deal with that and how to set that up, make it work. And I'm also going to show you what I call a blanket noise reduction using diversity noise canceling. In other words, a very broad range across a big part of the band. They require a slightly different configuration in the software. Very easy to do, but I'm going to show you how to do it. Okay. So that being said, the very first thing, let me get over here. I'm going to walk you guys through how to make this work and what is very important to consider in setting it up. Here we go. So what you're looking at is Thetis. Doesn't matter whether you're running MRXPS, the original version, or any variant of Thetis, who cares? It all works exactly the same. Now, remember, there's two things involved in making diversity noise canceling work. It's different than diversity reception. Diversity reception is just basically listening to two independent antennas, whether they're polarized the same or whether they're cross-polarized. You have a receive antenna, you have a primary transmitting and receive antenna, and you mix the two. That's diversity reception. Diversity noise canceling is a different animal. Okay, so the first thing, on and on, keep in mind there's two things involved here. There's gain and phase. Each one of those are incredibly important. Okay, so when you look at the Anan, if you look right here, you'll see your attenuator. These are key areas. I'm going to just demonstrate for you. I'm at minus 20 dB, which is where the Anan normally sits. I find that on minus 20 dB, the signal strengths on the Anan, on my system and my antennas, equals the receive strength on the 7300, almost perfectly. S units are the same. Everything's identical. Once in a while on the weaker band, on the higher bands, when the signals are very weak, I'll run the attenuator at 0. Incredibly hot front end on these radios, as anybody who has them knows that. So no need to run these on 0 dB. Of course you can if you want, but I'm going to show you how I do it. All right. So you'll see on your primary ADC, which is on the main GUI here, I have minus 20 dB. So if you open RX2, you'll see down here in the bottom left-hand corner, VFO B band. It's on the same band. Make sure your VFO sync is turned on up here I have minus 20 dB. And you can see, let me see, pen adapter. Okay, so I got rid of the waterfall. We don't need to look at the waterfall. So you can see that the noise floor, now the way my gradient spectrum is set up, okay, my noise floor is the green, and anything above the green is noise, right? So my noise floor right now on 80 meters is about minus 139 dBm. That's on the primary. That's VFOA up here. So what I do is I always start out with the attenuators the same for VFOA and VFOB. Now, VFOB is the vertical end fed. This is the screen on the bottom here, the spectrum on the bottom. That's what the vertical end fed is hearing. Now, when I apply diversity noise canceling, it's going to affect VFOA. Okay, I'm doing this in layman's terms so you guys can get your head around this and setting it up. Okay, so let me get, okay, there is the phasing control. And you'll notice on the phasing control, the receiver source, you always want this on RX1 and RX2. That's how I do it, okay? This is interesting. Your reference source. Sometimes I find diversity works better with this set to receiver 1. Sometimes it works better set to receiver 2. Okay, so what I'm going to do first is I'm going to target, if you guys look right here on the spectrum, it's going to be hard to see. You'll see this series of birdies right here. Okay, so this is on VFOA. So what I'm going to do, I'm going to actually close RX2 because it's really irrelevant at this point. I just wanted to show you how I set that up. Now, if you look right here, I'm going to put the VFO kind of right next to it. So if you look to the left of the VFO, you'll see these series of birdies right here. So what I'm going to do is I'm going to wipe those out. So let me make sure this is always on top so it doesn't keep disappearing on me. What I'm going to do is I'm going to kick in the diversity, turn it on, and I'm going to move this line right here until I can get that birdie to disappear. Let's say I was transmitting right there on that frequency, right? And it would be like a steady ee going on in there. Well, how do I get rid of that? It's actually, I don't know, it's kind of easy to see, I guess. Well, it's not really. I don't know. Is that easier there, guys? Don't know. Anyways, I'm gonna leave the RX filter right on those birdies. Hold on. Okay, and Martin, that's another thing I'm going to address. People think, and hi everybody in the chat, by the way. Who's in here? Of course, Andy. There's Big John. Jonathan, how's it going? Martin, I'm going to address that very thing you said because people think that this is only useful for removing localized noise. And remember I mentioned blanket, removing blanket noise. I use this a lot to drop the noise floor. A blanket drop across a huge portion of the band at a time to reduce the noise floor. And you're probably saying, well, why the heck would you want to reduce the noise floor at minus 138 dBm? Right? Why? Because I can. Hey, Bruce, how's it going? Okay, back to what we're doing here. So let me kick diversity on. Now, keep in mind, my attenuators are set both at minus 20 dB. I am set on receiver 2. So let's see if I can go to work and get rid of those birdies. Turn this on right here. You'll notice the minute I turn it on, the noise from antenna 2, the receive antenna, you see that noise floor? It just popped up. Now I've got a lot of blue coming across there. So if you look, you see these birdies in here. Let me see if I can remove that. Oh, there it goes. There it goes. Gone. So that's how that works, okay? I'm going to go in and I'm going to go ahead and I'm going to change the attenuator on the second receiver. Okay, so let's open this back up and let's open the second receiver all the way up to 0 dB. Okay, you'll see the noise floor skyrocket, and it just did. See the noise floor now? Minus 120. That's almost 20 dB higher, right? So I'm not going to touch this right now, but let's just see if we can do anything with that noise floor based upon this setting. And I'm doing this because I want you guys to understand that the attenuators are very, very important in making diversity work. You see, it has virtually no effect. So now I'm going to go over to receiver 1 on the reference source. Now I'm going to wheel this around and see what happens. Okay, so it looks like I can get my noise floor back. However, if you notice, I cannot get rid of that birdie. So this may be an effective tool. Where am I? Yeah, see, that's just no good. See how I'm basically wiping out. See where the bullseye is? It's all the way into the center. So that is a good indication of it being completely useless in that configuration. So what would happen if I change the attenuator on VFO-B to minus 30 dB instead of having it the same as VFO-A, minus 20 dB? Well, let's find out. Let me start working with the bullseye again. We'll kind of go around here. Okay, so that seems to work more on the blanket noise floor. Seems to be sort of affected, but you'll notice that birdie is still in there, right? I wanted to demonstrate this in real time so you guys could see what those attenuators do, how they affect the diversity, noise canceling reception. So let's go back to 20 dB. Let's lock it up with the VFO-A, and we're going to see if we can wipe the birdie out. Watch, it's going to make a liar out of me. Oh, I'm on receiver 1. I got to go to receiver 2. Pay attention. There it goes. Bye-bye. Gone. Gone. Okay, so that demonstrates that aspect of it. So what I'm going to do is I'm going to change bands. So let's disable diversity. And we are going to go to 40 meters. And I need to change antennas. Okay, that is the 40 meter array. Let's get diversity back up on the screen. Let's double check our attenuators. Okay, that's at minus 30. So I'm going to set that to the same right now. Okay. Let's get VFO-A back up. Okay, so my noise floor is roughly the same. Diversity is off. This is noise canceling. Diversity is off. It's at minus 139. All right. So let me see if I can get this so you really can see a majority. Yeah, so you can kind of see the majority of the band. It's blocking it here, up around, what is that, 265 probably. But everything down here, you notice that I really don't have a noise issue here, right? So just for fiddles, I'm going to leave it on receiver 2. And if we look at, let's go back to, you notice there is a little bit of noise in here, but you'll notice the receive. Look at the signals on receive on here. They're surprisingly good on that end fed. Now we're talking the difference between a 65-foot vertical end fed half wave on 40 meters and a 2-element full wave loop on 40 meters. Is it going to be as good on a receive? Hell no, it's not going to. But if you watch this signal right here, it's pretty freaking good. We got yellow and we got some blue. Yeah, it's not bad. So here's where diversity reception can come into play. There's two ways you can do this on the Anan. I'll show you the first way. Here we go. And this may be a blanket. Okay, so we've got, you see this little hump right here? Right here. Let me pull the noise floor up a little bit so you can see it a little better. See this little hump right here? Let me put the okay, so the RX filter is right here. See that little hump? Well, let's see if we can just get rid of that for figgles. It is insignificant, but we'll just try it. Okay, so I just kicked diversity on. Notice the amount of noise. Notice that hump is ballistic because I just brought that. It is very hot on the VFOB antenna, which is the end fed. So let's kind of wheel this around and see what happens, which pretty much does nothing. Interesting, huh? I'm demonstrating how important the attenuation settings are. Nobody explains this. So let's go over to receiver 1. Let's wheel this around a little bit, see what happens. Okay, gone. See, and look at the signals right here next to it. Didn't pretty much do anything to the signals, but it just wiped that sucker right out. You can still see it there, just a tiny bit. But so the moral of the story with diversity noise canceling on an Anan and an RSP Duo running SDR Uno, pay attention to your gains on each ADC, each receiver, very important, and choose on the Anan. See, this is a feature you have on the Anan that you don't have on the Duo. That's what makes the Anan so powerful. You can choose the reference source as receiver 1 or receiver 2. Either your transmit receive antenna or your diversity antenna. Very cool. Okay, so what would I do? Let me, so there's two ways you can run diversity receive on the Anan. One gives you a lot of control. The other is basically a mix function. Okay. It basically takes the two antennas and mixes them. All right. So, and you may ask me, or you may be thinking, well, even though the IF is there, is it actually passing the audio with the diversity antenna from the diversity antenna? And are you hearing VFOA and VFOB together when you're running diversity noise canceling? Yes, you are. Yes, you are. So here's the first way you can go about diversity reception with an Anan. You can use the diversity window, noise canceling window, right? And you can set your attenuator. Let's open up RX2. I know this is a lot to kind of get your head around. Forget it. Let's set this to 0 dB. Boy, she went through the freaking roof, didn't she? Look at what happened to VFOA. Look at how much noise came up. For this application, in this situation, it's probably not worth doing. There is another option, though. So let me go back to RX2. Let me change the attenuator. I'm going to move this to minus 30 dB. Now our VFOA is on minus 20 dB. Remember that. Okay, so what I'm going to do, let's get on, what is that guy on? He's on lower sideband. Okay, so he's about an S9. about an S9, maybe a little hotter. So you can go two different routes with this. You can do a blanket noise reduction across the entire noise floor. And I can kind of move this around and yet still have the benefit of a little bit hotter reception. So that's on receiver 2. So let's try receiver 1. See what happens there. Ignore targeted. Oh, it did take the targeted noise out. Okay, so if you look at this signal currently, he's about solid 5 over. Right, so what I'm going to do is I'm going to disable the diversity function. So he's about an S8, S9. I'm going to kick the diversity back in. Oh, this is another guy talking. Kick it out. 5.8, 5.8, 5.9. Put it back in. 5.9 plus. Take it out. Okay, now we're at 5 over. Engage it. 10 over. Diversity out. 5 over. Re-engaged, still at 5 over. 10 over. Okay, so what that actually did, now it may be insignificant to most people. What that does is you can do a blanket noise floor reduction across the band, and yet you can have the benefits of diversity reception with two different polarized antennas that can many times prevent the nasty fading you get through, the signal flipping and twisting and bending and doing all kinds of crap coming off the ionosphere. Having two different polarized antennas is huge. So I think that pretty much does it, except for one option. Let me, I'll take diversity out. And there's one other option that I don't hear people talk about very often. And right here at the bottom on Thetis is a button called Multi-RX. What that does is if you click that, you probably won't see. Now remember, your VFO sync has to be on. So you want your VFO-A and VFO-B to be synced together. So both VFOs are on the same band, same frequency, right where your RX filter's at. Now, more often than not, I will use that, but when I turn it on, it brings VFO-B in and morphs the two antennas together. I don't see an increase in signal strength, but oftentimes I hear a pretty stark increase in audio strength. I can't explain that, but other times, no, it doesn't work. So I just wanted to show that to you really quick. I have so much more. I have at least 2 other streams coming. One is coming at 2 o'clock, and I only have 15 minutes, so I got to get out of here. That completes that whole thing. So anybody who has an Anan, who was dying for someone to show a complete comprehensive setup on how to get diversity running and make the most out of it, there you go. That being said, that's all I know. Take it for what it's worth, but it's a hell of a lot more than what I've seen presented online. So it's long overdue, isn't it? All right, guys, I'll see you later. I'll see you in about 15 minutes, and the next one's going to be pretty short. Pretty funny, actually. See y'all later. Come back in 15 if you're around.